So I must apologize, ladies and gentlemen, because I couldn't help but to have a little Michael get us started on these notes. Now watch, they won't let me record this whenever I'm ready to record this, but we're going to find out anyway. So let's get in our notes, shall we? We talked a little bit about this in class, and so we're going to pick right back up. I'm just going to go over some of this stuff and do some examples. The product property and the quotient property. These properties, this one is probably the one I work with the most today. It basically says you can split up one radical into two different radicals if it's multiplying underneath the same radical. If it's dividing, should be a fraction bar right there, it's hard to see, but if you're dividing underneath the same radical, then you can separate into two separate radicals. It actually helps to do that in some instances. Now, before we actually get into the radicals, so what you want to know is that whenever you see a radical sign, that's a radical sign. The number out here is called the root or the index. All right? The root or the index. That's a slash, by the way, not lindex, like a L. Root slash index. And so what they're saying is that you can have a different number root there. Most of the time we see like the square root, so we call it the square root. Notice it says here if a equals 2, you don't write 2. You don't write that number. But if it equals anything else, you write that. Now I didn't write that down, so you might want to write that down. It's only if a equals 2 that you don't write the 2. We know that that's a square root, all right? This is called a cubed root, a fourth root, and so on. The index here is 3. The index here is 4. Now this right here is something that we're going to talk about later, probably not today, but that also equals the same thing. I said that in class that radicals also are rational or fractional exponents. So that's just a little background. Let's actually go back to the notes here. What we want to first talk about is how to simplify radicals, okay? That's important. That means that sometimes radicals aren't perfect squares. You got upside down division and you have separating a perfect square. I'll show you each one of these, but you want to go ahead and write this down. You might need to pause it. I'm not going to read it to you, but I'm about to show you and explain the process to you by working these couple of examples here. Actually, by working, yes. And so let's look at that. Get off. Not those, not those. These down here. The square root of 24. I want to work that out in two different ways. I want to take the square root of 24 and I want to solve it using square roots, and I want to solve it doing upside down division. Alright? So, here we go. Let's do square roots. I'm going to break this up into the factors of 24. 1 times 24, 2 times 12, 3 times 8, I want to say 4, and 4 times 6. Every single pair of these numbers equals 24. But I need to ask you which one of these are which one of these contain perfect squares? Well, this one and this one. Well, the next question is, what's a perfect square? A perfect square is the product of any number multiplied by itself. So 1 times 1 equals 1. That's a perfect square. 2 times 2 equals 4. That's a perfect square. 3 times 3 equals 9. That's a perfect square. Again, the product of a number times itself. So, can you name any more? I'll wait and pause. Name some. All right. So, 1 is a perfect square and 4 is a perfect square. It's not divisible by 2, but it means a product of a number times itself. So whenever you're doing it like this, you want to make sure that you pick the one that has the biggest perfect square in it. And the biggest perfect square out of all these pairs is 4. So I'm going to take square root of 24 and write it like this. 4 times 6. Now remember, there's a property that I just showed you that says if you got two numbers that's multiplied underneath the radical, you can separate that like so. Alright? Now the question is, what is the square root of 4? And that's 2. And you say radical 6. Sometimes we might want to add the plus or minus. just for the sake of these notes right now, I'll probably leave it off, but I showed you that, remember, whenever you take the square root, usually you have to also do positive and negative versions of that. So the simplified version of the square root of 24 is 2 radical 6. All right? And so that's the first example there. Now, let's do it doing upside down division. They call it upside down division because look at your division sign. It's kind of upside down. And the idea is you want to divide this number by the smallest number other than 1 that can go into 24. So it should be 2s or 3s or 5s all the time. Always a prime number. So it's not 1. So I wrote 2 because that's the smallest number that divides into 24. And so you say 2 go into 24 how many times? 12. All right, do it again. What's the smallest number that goes into 12? 2. Keep going with that same idea. Smallest number goes into 6, 3. Smallest number that goes into 3, whole number. All these are whole numbers. And you stop when you get to 1. Now, I'm not concerned about this stuff here. But all these numbers outside here are important. And since I'm dealing with a square root is 2. I have to have 2 of the same number to come out. So I got 2 2's, and so a 2 comes out. And I say come out, I mean outside the radical. So a 2 comes out of the radical. And there's not another pair of numbers. So you multiply each one of those, and those stay on the inside. Notice I get the same answer. 2 radical 6 and 2 radical 6. So it doesn't matter which one you use. This one you have to know and have a good understanding of what these numbers are, the perfect squares, in order to do that. All right? All right, let's look at number 2. Now, number 2, there's nothing really you can simplify here. The square root of 6 doesn't reduce. The square root of 15 doesn't reduce or simplify. When I say reduce, I mean simplify. But when I do this, then something comes of that. Now, when you say, where did that come from? Remember, there's a property that said you can multiply those two and make 1. If I did not emphasize this enough, and let me do this. I guess it won't make big. The point is that whenever you not do that, you can go either way here. You can go this way or from left to right, right to left. So I just said 6 times 15 is 90. Doing it the square root way, I know that this is the same thing as the square root of 9 times the square root of 10. 9 is the biggest square root in there. And so I know that this reduces to 3 radical 10. That's what that equals. Or you can do upside down division where you say 90 divided by 2 is 45. And that divided by 3 is 15. And that divided by 3 is 5. And that divided by 5 is 1, because that's the smallest number that can go into each one of those. Now remember, I said a pair of numbers has to multiply. Have to be out here in order to come out. So there's a 2 3, so 1 3 can come out. And again, why am I saying a pair? Because this is a square root. If this was a cubed root or fourth root, it would take 3 or 4 of those same numbers to come out. So a 3 comes out, and whatever's left over, you multiply and it stays underneath the radical. 2 times 5 times 1. And that's where you get your 10. I get the same answer here. Either way is okay. What about this one? The square root of 17, square root of 7 over 16. Now, that's the same thing as doing the square root of 7 over the square root of 16, right? You got this property here that says you can separate them. What's the square root of 16? That's 4. The square root of 7 doesn't reduce, so it stays just the square root of 7 over 4. All right? So those are those. Now, let's go and talk about variables. Let's talk about how to deal with these whenever you have variables. When simplifying variables, notice what I say here. I'm simplifying variables underneath the radical sign. And really, I should say the square root. This problem really deals with square roots, okay? This particular hint is really dealing with square roots. So make sure you understand it's not just radical signs, but you can use this for cube root, fourth root, or whatever. Notice that what I do is divide this into even exponents and odd exponents. All right? If it's an even exponent and we're dealing with a square root, you divide the even exponent by 2 for the variable that goes outside. And if it's an odd exponent, you want to separate them. In an example like this, you just take 1 away. All right? And notice now you got an even and an odd. And so what you would do is take the square root of both of those individually. And so let me show you what I'm talking about by actually doing this example here. Okay, First of all, hopefully you understand that this is the same thing. I can take both of those and separate them into two separate radicals. Since both of these, since this 4 is a 2, it's an even number, all I have to do is divide that 4 by 2, and this becomes x squared. This one right here is now x squared. All I have to do now is divide that 10 by 2, and this is y to the 5th. That's what that simplifies down to. So we prefer even exponents because it's easier whenever you're dealing with a square root. But what about number 5? Notice I'm trying to take the square root of both of these, and they're odd. Again, this is the same thing as separating them like this. You don't have to put the dot there, but I'm just used to it, I guess. What I wanted you to do in a situation like this is I'm going to take this x to the 5th, and I'm going to write it like this. X to the 4th times x, that's x to the 4th, I guess that's to make it bigger, times x to the 1st power. And I separated those. Why? Don't 1 plus 4 still equal 5? Remember the exponent properties? So I split those up, and now I divide this by 2. And so x squared can come out, but x to the 1st cannot, so it stays underneath the radical. That's how you simplify. Now, that's actually just that part. I shouldn't have boxed it in. Let's do the same thing for y. I'm going to say y to the 8th times y to the 1st. So you don't have to write the 1 if you don't want to. Now, I divide 8 by 2, and that's y to the 4th, and the square root of y stays on the inside. Now, that's not my answer because those actually go together. The total answer should be x squared y to the 4th, the square root of x, y. So I may have thrown you off at this stage right here by boxing those in because those are not technically the answer. The answer is when you put them both together. I just kind of got ahead of myself and boxed those in. But actually I took this x to the 5th, broke it down by itself, y to the 9th, broke it down by itself. Let's keep going. Now I have a number with a variable. And so I'm going to simplify the square root of 8. The square root of 8 simplifies to 2 square root of 2. That's what that equals right there. If you don't believe me, check me out. Upside down division or another way. R to the 6th is the same thing as r cubed because you divide it by 2, right? And p to the 7th becomes p to the 6th times p to the 1st, and that, when you take the square root of that, becomes p cubed, square root of p. So let's put it all together. Let's multiply all these together, and what do you get? Everything that's out of the radical is a 2 r cubed p cubed, and what's underneath the radical? We got 2 and a p. Ta-da! So I showed you each one of those piece by piece where they came from. It's kind of messy over there. That's p to the 6th and p to the 1st. All right? Up, running out of time. How do you work a problem out like this? Say they don't even have that. You just got 4 right next to the square root of 48. Like this problem here is just I ran out of a radical symbol there. How do you work this? Well, this is 4 times whatever you get for the square root of 48. So one more time, let's do upside down division so you can understand how to do that. I got the square root of 48. That's going to be a 2. 2 going to 48, 24 times. Smallest number in 24, 2 again. 12, 2 again. 6, 2 again. 3, and you stop when you get to 1. Smallest number that goes into both of those is right there in front of it, all right? Now, I'm dealing with the square root. So, it takes 2 for 1 to come out. But notice I got another pair of 2's. So 2 2's can come out. Whenever you have more than one number come out, you have to multiply them together. So 2 times 2 is 4. And whatever's left over, you multiply, and it stays on the inside.